Today, you'll be learning some more about dividing terms with powers. Let's take a fraction like a cubed over a to the power of 5. That really stands for 3a's multiplied together over 5a's multiplied together. Anything divided by itself cancels out, so you can pair up a's on opposite sides of the fraction bars that will cancel each other out. Notice how once a cancellation is done, there's no a's left on top of the fraction bar. So you would just write 1 on top of the fraction bar when there's nothing else left. There's 2 a's under the fraction bar, so that would simplify to a squared. So your final answer is 1 over a squared. Notice how this time your answer with the a squared, it's under the fraction bar instead of above like it was last time. And that's going to hold true anytime you have a fraction where the bigger power is under the fraction instead of above the fraction. To summarize the rule, you still subtract your powers, like you could do 5 minus 3 and get 2, but you have to be careful that you put the leftover a's on the part of the fraction that had the bigger power to begin with. Copy that down. Next, we'll work through question 1 together. You still follow the rule that because the bases match, they're both base A, you can subtract the powers. So you could do 7 minus 3 and get there's going to be 4 a's left over after canceling things out. The leftover goes in the part of the fraction that has the biggest power, so it would go under the fraction where the 7 is. So your final answer would be 1 over a to the power of 4. You always put a 1 in part of a fraction where everything else cancels out. Question 2. You have matching bases, they're both 3's, so you can go ahead and subtract the powers and get 6. But this time the bigger power is above the fraction bar. Where everything got canceled out, you put a 1, but anything over the power of 1, you could take off the power of 1 and just leave it as is, 3 to the power of 6. Go ahead and try number 3 on your own and pause the video until you're done. Check your answer number 3. Make sure you write in the invisible power of 1 on the m on top of the fraction so that when you subtract your powers, it's 6 minus 1. 5 m's left that don't cancel out. The bigger power was under the fraction bar, so it'd be 1 over m to the power of 5. Try the next 3 problems on your own. Pause the video until you're done. Go ahead and check your answers on 4 through 6. Notice how anytime when the bigger power is on top of the fraction, it ends up not being a fraction anymore because over 1 you could just kind of cancel out. It means the same thing as a whole number. Now, sometimes you have more complicated fractions. So for a problem like this, a good first step is to take the coefficients, the normal numbers that have no exponents, 4 over 8, and simplify just that part of the fraction. If I simplify 4 over 8, both the top and the bottom numbers divide by 4. So I could say 4 over 8 is really 1/2. That's step 1, simplifying the coefficients. After that, I'm going to tag on the a's and b's that have powers, but I'm going to space it out so it's easy to line up the a's over the a's and b's over the b's. And then I'll subtract the powers again. For the a's, 5 minus 4 is 1. I'm going to have 1 left over 8, and it's going to go under the fraction because that's where the bigger power is. With the b's, 3 minus 1 is 2, so I have 2 b's left, but they will go above the fraction because that's where the bigger power for the b's was. And I keep the 1/2 in front of the rest of the answer. Now, you want to write your very final answer in the simplest form possible, which generally means taking off 1's because you could always leave that invisible. Like 1 times b squared, you could write as just b squared. A to the power of 1, you could write as just a. So your final answer would be b squared over 2a. Go ahead and try number 1. Pause the video until you're done. First, you might want to space it out so it's easier to visually line up the n's in one column and the m's in a different column. And then you subtract your powers. For the n's, 7 minus 4 got you 3, but the bigger power was under the fraction, so it'd be n3 or n cubed under the fraction. For the m's, 8 minus 3 got you 5, and that would be m to the power of 5 above the fraction because the bigger power was above the fraction for the original problem. We'll work through one more together. First, I always like to space out my fractions so I could see how the like bases are lined up on top of each other, so you might consider rewriting it with space to create those two columns, one for the 2's, one for the t's. Then you subtract your powers. This time though, for both terms, the bigger power was under the fraction bar, meaning both the 2 and the t7 got canceled out. You just have a 1 left above. Go ahead and try all the rest of the worksheet on your own. Pause the video until you're done. For number 3, you'd first space it out and then subtract your powers. For number 4, this one has a coefficient in front. So I would take the two coefficients, the normal numbers without exponents, and simplify just that part of the fraction. Both 15 and 25 can divide by 5. Then I would tag on the a's back onto that simplified fraction. But I keep it spaced out so it's easy for me to see how the a's are a column of like terms. And then I would subtract my powers and put the leftover a's where the bigger power was in the original problem, underneath the fraction. Go ahead and wrap up 5 and 6 if you're not done. For number 5, you take the coefficients and simplify that fraction. And then I tag on the variables with their exponents and simplify those with subtraction. Notice how 5 minus 5 means there's 0 x's left. In other words, they cross out completely, no x's. So there's no x's at all in my answer. Sometimes I'll physically cross it out when I see they have the same powers in a fraction. And you know how we had 3 over 1 initially? Well, 1 y to the power of 8 is really just y to the power of 8. So the simplest form of the answer would be leaving off the invisible coefficient of 1. For number 6, you'd simplify that fraction, tag on the variables with your exponents and subtract, and check your final answer. Great job, everybody. Don't forget to turn in a picture of your filled out notes on Schoology.